Good morning, ladies and gentlemen of Algebra Honors. We were working on using a graphing calculator to graph these cubic functions, and we were just looking at doing some analysis of these. And we finished yesterday these first three rows. You remember that? Let's just continue. Okay, now the question, how many turning points does the graph have? Which brings up the question, what is a turning point? Let's just go ahead and graph these pretty quickly here. We have, oops, actually I want to go here. Okay, we have first one here, x cubed. So let's go ahead and put this up here. X cubed, and we graph this. How many turning points does this graph have? What is a turning point?
Isn't it?
Okay, a turning point would be a peak or a valley. There are no turning points, increases everywhere. So no turning points here. And then the next one is going to be, on here would be x squared times, I think it's quantity x minus 2. And so we graph this. How many turning points does this one have here? 1, 2. Turns from increasing to decreasing and from decreasing to increasing. And then the last one we have here is going to be x times quantity x plus 1, or x plus 2, excuse me, x minus 2. And then, how many turning points does this one have? 2 also. Okay, so none, 2, 2, right? And how many global maximum values, how many local minimum values are not global? Okay, that brings a new definition. And of course, the graph that's on the calculator that I have right now is of this function right here. And so I bring this up here. How many global maximum values do we have here?
2. Infinity 1.
Okay, what does global mean?
Everywhere.
It means everywhere, right? It means if we take this whole function, and we can only see a portion of it here, right? You can't see.
Negative.
And so do we see any values that are maximum values for the whole function?
Infinity. So
No, there are none. There are no global maximums or minimums, but we have local maximum and a local minimum.
Yep.
So no global, and another thing, instead of global, they call it sometimes as absolute maximum. And then there's extreme value theorem in calculus, okay? So anyway, what it is, how many global maximum values? So we say no global anywhere, right? No global for this one here or this one. Now it says how many local maximum or minimum values? Well, here there are no local here max or minimums, and here says how many local max values. Actually says, yeah, there's one local maximum value, right? So this is the local maximum value, which looks like it's about 3. So there's one local max and one local, and over here one local also, right? And now here we have how many global minimum values? Well here none either, right? And here it's also one minimum and one minimum here, one local. Okay, so really that's it for the cubic one here. So we're going to turn the page, and before I do that, I'm going to erase these 3 bottom rows. Okay, here we go. Now here we have these ones here. We have x to the 4th. We have this one here, x cubed times x, quantity x minus 2, and then we have x squared, x minus 2, x plus 2, and then we have x in all these. So we got 4 different things to look at here. And so this gets back to our cheerleading, doesn't it? So let's go put x to the 4th. So we put x to the 4th and graph it. And so that's x to the 4th. Okay, is this going to be odd positive, odd negative? Even positive, right? So odd positive, odd negative. This one here is even positive, right? Even positive. So let's just kind of go down the column here. And the column here, we go down, it says, how many distinct factors? Well, we just have one, right?
Yeah.
What are the x-intercepts? X equals 0. Tangent to or crosses the x-intercepts? Just tangent, right? Does not cross. How many turning points? 1 turning point. How many global maximum values?
None.
No, okay, no global max. No global maximum, and there are also no local either, right? What about minimum? How many global minimum values? 1. And then how many local?
1.
Okay, 1 global and also 1 local. How is that possible? How can they be the same thing? Yeah, so what happens is to look at global, you have to look at the whole graph, right? Everything, you have to consider everything. But local is just focused in on this. But that still is a local minimum, even though it is, all happens to be the same as a global minimum as well. And then the next one here, make sure I have it right. I want to make sure I get the right. It's x minus 2, okay, x cubed, x minus 2. X cubed times quantity x minus 2. So we have this right here. So is that kind of weird looking? Yeah, it is. Okay. That's what the thing looks like. So the first thing we're asked here is how many distinct factors do we have here? We have 2. Okay, we have x and we have x minus 2. What are the x-intercepts? X equals 0, x equals 2. Tangent to or crosses the x-axis. Well, this one here does what? Let's take a look at it again. That crosses, right? It's tangent and crosses, and also crosses x equals 2, so crosses in both places. So crosses at x equals 0 and also x equals 2. How many turning points? Yeah, 1 turning point. Here's 1 turning point. Not a turning point here, but a turning point here. Okay, how many global maximum values? None. Okay, none either. Okay, well, how many global minimum values? one global, and also one local, right? Okay, next we're going to look at this one here. So let's go over here. We're going to change this to, let's see, we'll change this to squared, and this one's going to be x plus 2. So here we have this one, and so that's kind of a, what does that look like?
Like a Batman W.
Kind of W, kind of a Batman. Although, yeah.
Oh, it's something like that.
Oh, I see it.
Yeah, huh?
I see it. Looks like a cat.
Like you.
Yeah, we could actually, and really what happens is what Marcus is saying is right. We go like this, right? If we go like this, what do we have, Marcus?
Got that Batman.
Batman, right? Recognizing the patterns, good work. All right. But anyway, we can see what it looks like. So let's go ahead and answer the questions. We have, how many distinct factors do we have here? We have 3. And let's look at we have our x-intercepts. The x-intercepts are x equal 0, x is equal to plus or minus 2, right? And then tangent to or crosses. Well, what are they tangent or crosses? So it's tangent at x equals 0, but crosses at x equals plus or minus 2, right?
Yeah.
So tangent at x equals 0 crosses at plus or minus 2. And how many turning points do we have here? How many turning points?
3.
3 turning points. So 3. So we made a quantum leap here. We went up from 1 to 3. How many global maximum values do we have? None. No global maximums. How many local maximums we have? So we have 1 local. And what about how many global minimum values do we have here?
2.
Well, it's kind of a trick question. I only count 1
They'd be the same, right?
because they're the same. So that's only going to be 1 value since they're going to be the same. So that's sort of a trick question, but we will say one global maximum value global minimum value, excuse me.
What about local?
Now, local's kind of hard
Would it be 2?
because there are 2 local minimums, but they happen to be the same value, right? So 2 locals, we'll say 2 locals, but they're the same. Yeah, so that's a trick one, right? But the same. But the same value. I'll put value right here. Yeah, all right. Okay, now the last one here, we're throwing here this x minus 2, x plus 2, x plus 3. So let's go ahead and fix that. So I'm going to go ahead and erase, delete that thing here, and then come over here and put x plus 3. So here, this is what this thing looks like. Okay, so it's getting a little more wild, isn't it?
So do you have 2 minimums or 1
You
minimum?
have 1 global and 1 local, 2 local, right? No.
So here's this one down here, and what I'm going to do is I'm going to expand the window a little bit so we can actually see this, what's going on here. I'm not sure if this will get it, but let's try to get it.
Yes.
Yeah, it does.
You got it?
Gets it, okay? So we can see everything here. So let's go ahead and answer the questions. How many distinct factors do we have here? 4. What are the x-intercepts? x equals -3, x equals -2, x equals 0, and x equals 2. And tangent to are crosses at x-intercept, so crosses everywhere, right? How many turning points do we have here? We still have 3, right? And I want to tell you, I want to interject here, is that there's a kind of a rule of algebra, and that is the number of possible turning points of a polynomial function is going to be 1 less than the degree of the function. So this is degree, these are functions, each of them of degree 4. So what's the maximum number of turning points we can have from this? 3. Okay. So we're all kind of getting toward the fundamental theorem of algebra. How many global maximum values do we have here? Well, we don't have any globals, right? So no global.
No, one local.
Okay, how many local maximum values do I have here? 1 local. And how many global minimum values do we have here?
2.
1 global minimum.
What? I thought we had 2. Oh.
Okay, let's go ahead and look at the graph again. When we say 1 global, we look at the whole thing. When we look at the whole thing, how many global do we have here? Just this one.
Yeah.
Okay, so we have to just kind of step back and look at the whole thing. So it's more like a 30,000 foot view, right?
Yeah.
But then we're going to look closer at these minimums, and we see that we have 2 local minimums, and they are different, right?
What's today?
Okay, and they are each distinct. I'll put each distinct.
What's the code?
Walker 27.
Each distinct values. So those are just some characteristics of cubic. And what do we call degree 4? What's the word for degree 4 function? Polynomial function?
For degree 4?
Quartic. Who said
Yep.
quartic? Get Randy. Right.
Randy.
Quartic. Thank you.
Double R.
So we're going to start working on these exercises for 6.2.
Yes, sir.
And
At 8 minutes.
Want to add me?
hand these out.
Go watch that.
You gonna go watch that?
Oh,
Yeah.
and I don't have a good idea right now how far
This is
we
my
can go.
girlfriend.
She's at this place, right?
Oh. Right. Why not? You know what I said.
Talking one date.
Huh? Everybody ready.
Got a date.
Happy birthday.
Yes.
What is that? Digging. I'll get in this for free.
What do you do?
All right, back to this one. Erase all this.
What's the day to do?
Huh?
What's the day to do?
Jaden? Yeah.
Okay, so now here we are to problem 1. Use a graphing calculator to graph the polynomial function. Use its graph to determine the function's domain, range, and end behavior. And so I want you to go ahead and do number 1. This is f of x equals x to the 7th power. If you don't see that. And then I'm going to go ahead and call on somebody to give me the answers for number 1, okay?
For number 8.
You're doing right.
Oh, we got the back.
This domain.
Oh, this one?
Number 1, yes. So I want to choose somebody.
You want to do one?
Yep.
There you go.
We enter it later.
Oh, I didn't remove Aaron from the list here. He's not going to be here today.
Oh, yeah. Oh, yeah.
Oh, yes.
So Kindle is not Amazon today. She's just Kindle. All right, Kindle, what do you have here for this? What's our domain?
What is your domain?
Shoot.
What is domain?
About 2.
Okay, domain is going to be all real numbers. It's the same thing for every polynomial function. Okay, that's our domain. What's our range going to be?
All real number?
Same thing, okay. What is our end behavior as x approaches infinity? F of x approaches infinity, okay. Other end, okay, as x approaches negative infinity, f of x approaches, did you say negative infinity? Okay. Does that look right?
Yep.
Okay, good. All right, well, so the next one we have is f of x equals negative x to the 9th power. So I'm going to call on somebody else for that one here in just a minute or so.
Whoa, 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 ow, whoa.
Domain is the same thing. Right.
It's going like that.
Okay, let's go ahead.
Come on.
And we have for this one, let me shuffle. Jose, okay.
Jose.
All right, Jose, what do we got here?
So isn't this an all real number?
So domain is all real numbers?
Yeah.
And what is our range?
Also all real number?
Okay, range can be the same here, right? Okay, and now now the end behavior as x approaches infinity,
Okay.
f of x approaches
Negative infinity?
negative infinity, okay? Does that look right?
What is that?
I think so.
Okay, as x approaches negative infinity,
What you think?
f of x approaches
Infinity?
infinity, okay? So, thank you, Jose. Any things to add for Jose? Okay, to me, this one and 2 is just, to me, just a real good example of number 1, all positive, problem 2, all negative, right? So that's that. Thank you.
Good job.
And we'll get started on 2 and 3 and 4. Erase these guys. So go ahead. This one here, 3 is x to the 10th. If you have trouble seeing that. So I'm going to call on somebody here in half a minute.
Is it going straight up?
No.
know, it's weird.
Mark's really, how did
It's got like a little curve. Should be all the numbers.
our numbers mark?
Range over.
So x to the 10th. Shuffle.
Be 0?
No. Let's go.
Oh,
All right.
Oh, it touches you.
What do we got here for our, Chloe, what do we got here for our domain? So like this? What about a range?
Isn't it 0
0
and
to infinity?
So
Like
that
this? Like bracket here,
Yeah.
parentheses here, okay, it's a range. Next one here, end behavior as x approaches infinity, f of x approaches infinity, as x approaches neg infinity, f of x approaches infinity also, right?
oh, you got it.
Okay, questions on that?
Negative x.
So in half a minute, I'm gonna call somebody to do number 4.
Good job, Chloe.
Well, you're best.
All right, here we go, number 4.
Already?
We're already done. Be good work.
Game, right? All right, Braden, what do you got here? Domain. All real numbers. If I think about drawing infinity, I have trouble doing it. If I don't think about it, I can do it. Okay, what is our range going to be?
Negative 0.
Infinity, 0. Okay, what goes over here? Bracket, okay. Okay, next, end behavior as
X approaches infinity. F of x approaches infinity.
Oh, you
you meant to say negative infinity, right?
Okay, so yeah.
Okay.
what? Oh,
As x approaches negative infinity, f of x approaches
Negative infinity.
negative infinity. So this is a good example of what?
Negative.
Even positive.
Even
Negative
positive.
positive.
cheerleaders.
Even positive,
Even negative.
even negative. See, look at,
Negative, like,
see, I got Haley. Haley's already doing the cheer. Okay? She's all ready to do it, right, Haley?
yeah.
All right.
You only got a strap on.
What?
You got a shirt on.
Got that shirt on?
Huh?
What did you say?
You got that strap on.
Okay, next. Go ahead here. Erase these guys. Okay, next says 5 and 6. Use graph calculator graph function, then use the graph to determine the number of turning points and type global or local, but not global of any maximum or minimum value. So this 5 and 6 are building upon the exercise we did where we talked about the turning points, right?
Yes, sir.
Yeah.
So I don't know what you want to do for these,
Just skip it.
but
With the page.
here we have x plus 1, and then we have x minus, what was that?
X plus 3.
X plus 3, right? X plus 1, X plus 3, here we go. X plus 3. So what I'm going to do is this. I'm just going to delete here. And I'm going to have everything in place, right?
Yeah.
So graph, so that's what you have, right?
Yeah.
Okay, I want to call on somebody for number 5. So here's number 5.
It'll be Mark.
It's gonna be Haley.
Ziggy.
Ziggy.
What are we doing?
Okay, number 5, when you graph the function, use graph to determine number of turning points and type. So how many turning points do we have here?
We have 2.
Let's go look here. You see those 2 here?
Yeah.
2, okay. So 2 turning points. Okay, then it says the number of type of any maximum or minimum values. So what are the number of maximums we have here?
You got 1 global and 2 local, I think.
So 1
Wait,
local maximum.
would be 0? Or would it be 1?
I'll just read it max. So here's our local maximum, right?
Yeah.
Okay. And how many local minimums do we have here?
1. Whoa.
Do we have any global maximum or minimum values?
No.
Yeah. So no global max or min, right?
Yep.
Or min, say, okay? So that's that one. And so next we go to problem 6, which we have 20x plus 1 squared, then x minus 1, x minus 2.
Can we do this?
So x plus 1 squared, x minus 1, x minus 2. Yeah. X plus 1 squared. And then it was x minus 1, x minus 2, is that right?
Yes.
Yeah. So this is what we're looking at right here. Okay, so we can see where the thing touches or crosses. And our featured victim on this is going to be Haley. All right, let's have it.
Turning points? I don't know if it's 2 or 3.
Let's count, let's go look and count. 1 turning point. 2 turning point, 3 turning points. I count 3. So 3 turning points, right?
Out of 5.
Okay, what about maximums and minimums?
There's one local max.
So 1 local maximum. Okay,
And there's 2 local minimums.
so 2 local minimums
And 1 global minimum.
and 1 global minimum. Okay. I'm using MIN and max, so and right here, let's make sure she's right. There's your global. So both of these are local, but this one down here is also global, right? All right. Questions on that one?
Go Haley.
Okay, let's go to the next set here. Maybe have a good idea. We're sort of learn a little bit more class time at this point. Yep. That's the way class works. Okay. Let's go to, whoops,
Yeah.
erase these here. All right, so the next one we have is just get through it, here we go, 7.
Aaron,
Here's Aaron, should have erased it.
it wasn't gonna be right.
Here we have
Let's
Lexi.
see.
Okay, Lexi, what do we have here?
I don't know if it's working.
So negative x minus 2 squared. Oops. Like this.
Yep.
Okay, so how many turning points do we have here? So 2 turning points. Okay, and then what about maximums and minimums and all that business? What do we have here for maximums and minimums?
I don't really.
Okay, what we're looking at, I'm just gonna go ahead, I'm looking at right here, so that's what the thing looks like at 0 and 2. So at 0 and 2 are, so we have this thing going like this. Right?
Yeah.
Okay. What, and let's look at the turning points. We have 2 turning points. We have one right here and one right here, right? Those are the turning points. What can you say about this turning point here? That's a minimum, right? So that's going to be, we would call this 1 local minimum.
So there's 1 local max.
1 local minimum, which is right here, and you say 1 local maximum too? Yes. Now, are there any global maximums or minimums?
That's a negative
No.
G.
No global maxes or minimums here. want to do is number 8, and probably be the last one today because of just lacking the class time.
Is that a cube or is that square?
This last one's going to be Bryce.
Yes.
So Bryce.
Is it cube or square?
That last one looks like cubed, right?
Yeah. We scored all the ones. Whoa.
Whoa.
Look at the giraffe.
Bryce. What do we have here, Bryce?
I got a hard one.
Bryce, you got it, bro. I think it's like
1, 2, 3.
4 times.
So negative x minus 1, x plus 2.
Yeah.
Okay, so I can do, I'll let you go.
Is it x minus 2 cubed? Is that right? Is that it, Bryce?
Whoa. So you got 3 turns?
X minus 1? Oh, a negative x minus 1.
Oh.
Yeah, it's going to be negative x minus 1, so I'm going to go like this.
What is he doing?
Actually, it's going to be negative on that side. Okay, let me do this. Negative x minus 1.
Yeah.
And this one here is x. X plus 2 cubed. So, right, that's what it looks like?
Looks like a giraffe.
There's not 2 locals.
So how many turning points do we have here?
I thought 1.
That's 30.
I'm looking at 1 turning point, right here, right? That's 1 turning point. And then it says, what about, do we have any minimums? No. But we have how many maximums? 1.
Yeah.
That is both global and local, right? So that's going to be that one. I don't have time to really write it down, but we're going to just resume next time. I can take care of the desks. We just kind of ran out of time today. Just hold on to this. We will work on this some more on Monday.